All right, let's go ahead and get started with miscellaneous operators. In the miscellaneous operator, we have basically another column, that's the colon, and another operator is here. In operator, you can say something like this. All right, there is a modular sign, and then in, and then again a modular sign, which is also percent sign. All right, there is another one, is there the modular sign, and then star, then there is modular sign. So what are meaning of each operator? This colon operator creates the series of number or sequence of numbers. All right. So this one is used for in creating a sequence of numbers, and this one is used to if a particular element or value belongs to a vector, and this one is used to check that this one is actually used to do a matrix operation with its transpose. So that means you can say matrix multiplication, and thereafter it has its transpose. So you can say something like this. There is T for transpose, then you have this matrix. All right, so it's like this. Let's go ahead and check it. For example, if I say here A is equal to 1 to 10, so it's going to create a sequence of number from 1 to 10. So this colon is used for a sequence operation. And you can also use it for any sequence creation. And thereafter, another one is in operation. Let's say we have our, once again, assign A is equal to 10. And thereafter we assign B is equal to 20 and C is equal to 30, and we are going to assign all these A, B, sorry, we need to also run this. So we have A, B and C. Thereafter, I want to check it. It says that you see that if a value belongs to vector, I think one thing I have finished there. I do not need this one. In fact, there you have this one, and B is equal to 2 and C is 30. All right. So this operator is used to check if a particular value is belonging to a vector. So I'm going to check if 2 belongs to this vector or not. So it says that it's pretty much simple. B, there is a percent sign in, all right, then A. So it says that true, that's when this value is a part of this one. So this is kind of getting as yes or no for a particular value if that belongs to a specific vector. And similarly, if we check here something like this, in A, this is going to be false because 30 does not belong to vector A, because the vector A is having only the value from 1 to 10. And the another operator which we have is multiply the matrix transpose. So let's go ahead and create the matrix first. So creation of a matrix, I'm going to do here M1 equal to, and if you remember, I also have shown you C is used for a vector generation. All right, and there I'm going to generate here 1, 2, 3, 4, 5, 6. All right, so this one is actually generating a vector. This is not a matrix. Either you can say this is a matrix, but there is only one dimension in the matrix. So I'm going to say here this matrix, and in that particular matrix, I need to put it inside this column. And if I run it, there you get this matrix. Now M1 is belonging to a matrix and it is having only one column and there are many rows. And if you want to reshape it to number of rows and a column, so simply you can say number of rows you want here 2. So there you have got there 2 rows and 3 column. All right, so it says that the 2 row and 3 column, this has been there. And thereafter I'm going to simply do here there M1, there is 2% sign, and then I'm going to do here a multiplication with the M1, and then I also need to put here it's like a transpose. And now if you run it, you will get there M1, this matrix, and the transpose of that matrix is multiplied. So this is all about in this lesson. Thanks a lot for watching it. I'll see you next lesson. All right, so in this lesson, we are going to see what is a function in R. Function is a set of statements organized together to perform a specific task. Mean to say that we have all these statement here, and when we organize all these statements together, and we can call all these statements together by just calling a particular name, then we can say that we have created a function. All right, so let's go ahead and see how the function definition is. So it's like this. You need to write there your function name. All right, so there your function, and in that you write there a function. This is function is a keyword in R, and thereafter you pass here the parameter 1. So we can simply say that, okay, this is param 1, that's the parameter 1. There is parameter 2, which is also the argument. All right, and similarly you can pass here multiple parameters, and thereafter you have something like this. Let's go ahead and put it like this one. All right, so you put there a curly braces, and inside the curly braces you write your statement, and this one is known as function body, and the earlier one is known as a function definition. And in the function body, I'm going to do like this. X is equal to, I'm going to do here, I'm going to perform here exponential operation. So the parameter 1 and then exponent param 2. All right, so that is going to be the parameter 2. And then finally, I return this x from this function. And thereafter, you can simply select all these together and then hit the control and the enter. So this whole function will be executed, but at some point it says that, okay, so this should be actually this one. So there is one more error here. This should be inside a round parenthesis. All right, thereafter select all this function and then finally run it. So it's running successfully. Thereafter, you can just call this function by calling with its name, and the name of function is pure function, and it takes 2 parameters as input parameter. So I'm going to give here the 2, 4, and it should return a result as 2 power 4, which is 60. And similarly, if we say that, okay, 2 power 10, so there 1024. This one is user-defined function. Now let me tell you once again, this name is known as function name, and these parameters are known as argument, and these particular values are known as a function body, and then finally this return is return value. So we need to put all those variables or particular value which we want to return from a function. So this one is user-defined function. There are many functions which are actually built-in function, and the built-in functions are like, let me tell you the built-in function. So the built-in functions are like mean, we have their sum, and then we have their variance, and similarly we have their standard deviation, median, and SQRT. These are the statisticals. There we have the sequence. Previously we have seen the matrix. So all these are actually built-in function. All right, so these functions run a specific set of the instruction when we call these function by its name. Let's go ahead and see some of the example. The first example I'm going to say here, sum 1, 2, and when we execute, it says that 3. There is another one, when I say the mean 1, 2, it says that the mean of 1, 2, it's saying there is 1. It's actually getting the median perhaps there. All right, so it's just producing the first one. And if we put it inside the actual vector, all right, so let's go ahead and put in the vector. As you know, we can create a vector by calling this C function, and if we run it, now it says that, okay, we are getting there 1, 2, and 1. And we can put it like, let's say, the result equal to, this one is equal to, let's go ahead and run it. And thereafter, if you see this result, we are getting 1.33. So the earlier we were getting confused because when we run this particular, it has just printed this whole value. And when we run something like this, then we will get whole result in this particular variable. And similarly, you can call other variable. Let's go ahead and call this square root. So in a square root, we are calling here the variable. Let me see here. We have M1, that's the matrix. There we have A. So I'm going to just pass there A. And once we pass this A, it is going to take the square root of A value. So these are the A value, and these are the vector. And then this is going to take the square root of each of these vectors. I mean, each of these values in that particular vector. So the square root of a 10 is 3.162278, and so on. This is how you can call the built-in function. And if you have any specific task to do, then you can create your own function in R program. All right, so this is all about in this lesson. Thanks a lot for watching it. I'll see you in the next lesson.